Okay, this video is going to cover circulation, stairs and ramps. We're going to just talk a little bit about what you can do with stairs and why stairs are such an important feature of your building design. And then we're going to look at how you actually work out the size and the number of stairs, how you fit those things into building regulations to some degree, and make it use of stairs as a design element in your building. They're not a thing that holds you back. They should be a thing that helps you to express your design ideas. And they are creative opportunity, like everything else in the constrictions of designing for the real world. And we're also going to be looking very closely at how drawings, technical drawings, express design ideas with regard to stairs in particular. Okay, so let's have a look through there. So we've got some examples. Here's a very famous staircase in Venice, in Italy, designed by Carlo Scarpa. And what's great about this is materiality, the fact that it's made of, and very obviously made of, a very heavy material, marble, and yet it appears to float. The design intention here is to have this juxtaposition between heavy material floating in air. And that's done technically by cantilevering these individual stairs out from the wall. And they are carefully arranged, obviously, to provide a comfortable path from one level to another. And they're not constricted in terms of the breadth. So sometimes they move beyond the breadth of a kind of parallel set of steps going upwards. And they give an expressive sense that connects with materiality and the other volumes within this interior space. So if you look across, you can see that this is for Olivetti showroom. You can see the Olivetti typewriter here on the right-hand side, sitting on its plinth, expressed in very similar material to the steps on the staircase as well. So there's a rhythm, there's a harmony, there's an expression where the steps and the stair belong to the interior design, belong to the architecture of the building and the space. Likewise here, we have a semi-sunken room in this building. The idea being, the design intention here is that you've got this kind of forest exterior, and then you submerge yourself from that into this kind of cocoon-like interior space, and you emerge from that cocoon-like space by traversing up and down these steps. So you're never fully below ground, and you're never, in a way, you have to use the steps to get above ground. So these are not full height steps, leaving from one floor that is below another floor, but they're a split level. So you're going up from a lower level to a higher level. You move up this, what appear to be floating steps, and emerge into the forest within this design idea. So it's an expression, it's an emphasis, a re-emphasis of the design intention of the architects here to produce a space which has a particular feeling. And part of that is that they wanted these steps to behave or appear as if they are floating in the air. And obviously that's done by cantilevering out from the wall. It's quite possible to do that. It works very well in interior here. You know, there's no handrail or anything like that. So this is allowed from building regulations. But it wouldn't be allowed in a public space with lots of different people using it, for example. But that's just how it works here. Quite another famous set of stairs in Scandinavia, Central Bank. And here the stairs are like a sculptural element within this space. The space is very monolithic, giant auditorium reception area for this institution, which has to appear very solid and reliable, it being a central bank. And so the materiality of this space and the height of this space suggests permanence, it suggests scale, it suggests security, which is what banks are obviously about. And then this staircase is an expression of life and energy, precision. It's very regular. There's a repetition here of the same elements being used over and over again. So the actual steps themselves are almost exactly the same when each time they appear. As you traverse up here, the landing The landings on the right and the landings on the left are made of the same material. Obviously, the landings on the left connect with the other floors, and there are doorways and passages moving off into the distance. The landings on the right-hand side of the staircase, going up this side, are merely returns. So you go up one flight onto the landing, return, and come back. And so it arranges, this means that the floor entrances to the floors are arranged vertically above each other, and these kind of return landings also arranged vertically above each other. So here a staircase as an expression of life, energy, organization, care, and a sculptural element here within this space. And here is Atelier Bow using stairs in a design of a very compact house in Tokyo. And the stairs here are very, very lightly created. Materially, these stairs are formed of almost nothing. Metal bars, metal steps. Very, very thin indeed. If you look at the thinness of the steps, they're floating here. They look almost like shelving. But what this stair achieves is to provide a connection between the spaces. If you look at the model on the left-hand side, you can see a number of these spaces are split. So you've got some double height spaces here and here, and you've got a split. So because the stairs are not walled off, you've got these vertical bars providing structural integrity for the stairs and supporting the steps. Light can travel through this building via the stairwell. So that, if you built a wall around the stairs, then the stairs would be a separate space, and it would obscure and stop light, and field of view would be obscured as well. You can stand and you can see some of these photographs. You can look up and see people sitting on the floors halfway above your floor. You can look through and down. You can see people traversing through the building. So obviously these steps are in a domestic interior. Once again, wouldn't work in a public space because they prevent lots of risks. Present lots of risks. It'd be very difficult for children to live here, for example. But they do achieve this ambition of connecting visually all the spaces within this building. So you do feel, even though there's a tall, narrow structure, all the spaces are connected together, and light and vision can travel through the building. And here is another example from Japan of a building which is obviously quite well known as an architectural test piece, really. Very, very permeable in terms of it being glass walled in the exterior, and you can see how the floors are broken up into multiple levels. So there's less of an obvious first floor, second floor, ground floor, and you have all of these splits, and you have stairs forming all sorts of connections in lots of different ways between those split level floors. Sometimes the stairs are a bit longer, and sometimes the stairs are very short. If you look at the bottom left-hand picture here, you can see the steps here are actually just 3 steps to get between these two levels. And sometimes the stairs are, sittable on and more a piece of furniture, and other times they're providing an access function. So this is a tightly woven, complex series of levels where the stairs play a very important part, obviously, of moving people around those levels, but providing another variety to the spatial experience in this building. And here's a kind of a logical extension of that, where the attempt is to remove a sense of steps or stairs altogether from the building, and yet still provide vertical access. So by breaking the floor up into lots of almost evenly sized floor planes, and then offsetting those more or less at 1 or 2 step heights from each other, you move through the building either constantly going upwards or constantly coming downwards, depending where you're going. And the sense of actually having a set staircase is removed or negated to some degree, although there are stairs in here to get from the garage level up to the first floor. And I don't know what's happening in the background, but there might be some steps behind as well. This is a kind of, at the moment, well, certainly this visualization is a visualization rather than a realization. I'm not sure if this building was ever realized, but this is an attempt once again to still provide vertical circulation without having a separate staircase to provide that. And we move on to think about ramps. Ramps are another way of getting people to move through a building vertically. A very famous example is this with the Guggenheim, obviously, in New York, Frank Lloyd Wright's building, where the gallery levels are on a continuous ramp, circular ramp that moves around the interior of the building. And you traverse this either from the bottom downward, upwards, or top downwards, and you're kind of moved through the space, not being very conscious of the fact that you're ascending or descending. And that is reflected also, the fact that this interior circulation methodology is reflected in the exterior design of the building. So you look at the outside of the building, you see these, you see that you're very aware of the curved nature of the space, and you've got this broken up vertical or horizontal bands showing this idea that inside there would these be different floor levels. And you can see photographs of the inside and outside, and you can see this relationship between these two things. So the thing about ramps, of course, is they provide a very subtle, or depending how sloped the ramp, steeply sloped the ramp is, quite a subtle sense of movement through vertical space, but they occupy a lot of horizontal space to do that. So it's quite an ingenious way to put it on a curve, minimize that. This is another famous example of a building where circulation, and ramped circulation in particular, is very significant. The Kunsthal in Rotterdam by OMA. It is, from the outside, a building that looks like a square, very rectilinear shape, very regular shape, but actually has quite a complex circulation pattern inside, largely based around ramps. And some of the ramps cut through the building, as you can see from the photograph on the bottom right. This provides a pathway from the park area where these people are coming from, upwards or downwards, to a dual carriageway, a major route through the city, on a dike, because out of Rotterdam being in the Netherlands, management of water, very significant part of urban design, spatial design in general. So this is actually a building on quite a complex site, although it looks quite a simple building. It's a very complex site and very complex building. And here's a diagram showing that the building has been conceived of this continuous circuit. And if you're ever in Rotterdam, I thoroughly recommend going to experience this building. The ramps that move through the building have lots of different spatial experiences within them. So sometimes the ramp is an auditorium with seats on it, and you walk up the side of that. And sometimes the ramp is narrow, and it's enclosed within concrete. Sometimes it's narrow and exposed in metallic. So the experience is very variable, as well as being in changing direction, left to right, right to left. And another famous example of a ramped organization, a ramp building, is the OMA Seattle Central Library in America, where the books are arranged on a ramp. So all the books are experienced by wandering around this circulation, ramped circulation. The books are all in that way organized in the building. And here's some more examples of stairs and rendered or created in different ways. So here is a stair imagined as pieces of furniture, so more or less looking like shelving coming from the floor above, and a piece of furniture, a desk, if you like, and shelves going upwards. Not quite meeting in terms of the same object, but obviously materially these two elements are rendered in the same materials, belong together. And obviously the steps that you come down are a little bit longer than normal, but you've got offset smaller steps to one side. So the idea here is that without all of this material on these steps, you would be able to go left, right, left, right, left, right, up and down here. Yeah, quite an unusual set of stairs. Here's some stairs, social spaces, or have been used as social spaces. These are the famous brownstone houses in New York, where the stairs are designed to get people from the street into their houses. The wealthy people who created these and built these houses, commissioned these houses, lived at a level above the street, so they could overlook the traffic that was on the street, the horses and the carts in those days that were going past. And so the ambition and the design purpose for these buildings was to create a space that was elevated above the street, where people would look out and be looked at from the street. Obviously, the social uses for these buildings have changed dramatically since they were conceived, and now these steps provide a connection through the street, so people can sit on their steps and look across and see their neighbors on their steps, and you can have communication between different households, as you can see in these steps, in these examples here. And here's a building in South London, once again, where the circulation via a broad set of stairs provide this opening through the space. You can see light coming in through the building, light being able to pour through the building because of the nature of the organization of the stairs and circulation in this space. Create this central opening through, vertical opening through the building. And then also on that to expand out from the stairs to provide auditorium seating. This is an educational institution as well as a practice for psychiatric medicine. And it's also used by lots of people, lots of students. So the stairs are very carefully organized to cope with large numbers of people. That's why they're very broad and very secure, handrails and so on. So, you know, multiple uses for the stairs here, not just a single purpose of providing access vertically through the building, but providing light and teaching and connection. And here is temporary staircase in Rotterdam once again, built as a kind of demonstration, a celebration, to take people from the ground level up to the top of quite a tall building. And you can see here, it provides this a huge statement in the city centre. It attracts a lot of people. At the time it was a temporary exhibition, temporary space. And what you can become aware of in something like this is a giant ramp of stairs from the ground upwards, is how frequently you need to have landings, resting spaces. So the resting spaces, the landings, provide this interruption to the stairs, this rhythm, this separate rhythm to provide rest. So you can only have 13 or 14 steps before you have to have a ramp for a landing, and obviously handrails as well. So although you've got a very broad staircase, very wide staircase, you need to divide that up with these handrails. But there are gaps in the handrails to provide possibilities to move across as you go. Okay, so that's the mechanics of providing a giant staircase and still allowing it to be a comfortable experience for your users in this context. So, what is the difference between ramps, stairs, and ladders? And what are we talking about when we're talking about moving people between one floor and another? The key thing here is the pitch, the angle of the system that you're using to move people. If it's shallow, in other words, like at the bottom example, 9.5 degrees or so, and you've got the space, then you can move people up a gradual slope or a ramp between spaces. But you'll notice from this example, you can see that ramps require lots of horizontal space to achieve that gentle movement from one level to another. If you haven't got so much space and you need to move people more efficiently, then the staircase is going to be the way to go, and it's going to have a steeper pitch. So the top example, for example, is 32 degrees. And there is a range. There's a range of acceptable pitches for staircases and a range of acceptable pitches for ramps. Because you can imagine that at some point you get to a position where a ramp is too steep to walk comfortably up it, or a staircase might be too shallow and too annoying to walk up it, or too steep once again. So there are ranges of pitch, and within those ranges, a ramp may be acceptable and useful, or a stair may be useful, or beyond the stair, a ladder might be the only solution left. So here we have what those ranges are in pitches. So you can see that up to 10 degrees or so, ramps are acceptable and workable as a way of providing vertical access to move between spaces, levels. And then between 26 degrees and possibly up to 50 degrees, staircases will work. Most common staircases and public staircases will need to be at the bottom end of that. So around the 35 to 26 or so degrees pitch is where you'll find most staircases that we use in public buildings are in that order. Once you get beyond that, it starts to get a bit steeper, and that might be acceptable in a house, private house, somewhere like that. But there will be limits there, and it will, in terms of especially coming down, how safe it is to come down. And then beyond that, then we're going to, as you move towards the 90 degrees of vertical, then we're talking about ladders. But what you'll notice from this graphic is that there are gaps between ladders and stairs and between stairs and ramps. And in those areas, we aim not to put anything, because basically ramps are too steep beyond 10 degrees. Stairs are too shallow below 26. And if you've ever tried to walk up a very, very shallow staircase, it's very inefficient and very annoying. And you notice that beyond 50 degrees, the staircase would be really, really steep, and it would be very hard and dangerous to climb. And below 65 degrees, a ladder would be annoying as well, because you'd be setting yourself up to use your hands and your legs to climb the ladder, and you'd be a little bit too horizontal, and you'd be worried about slipping through the holes. So actually, if you think about it, there's just these 3 bands where you can comfortably place these different ways of moving between vertical space. And one of our earliest experiences getting to grips with this is obviously as children and climbing frames. And we're working on our manual dexterity and our physical health. And here you can see an example where we've got various kinds of vertical ladders, climbing frames, rope ladder, which is angled at quite a gentle angle for a ladder in the background, a slide, all sorts of ways, and the climbing wall and so on. So these are ways in which we've become familiar with moving around and develop our manual dexterity. And these are obviously been designed to help us be efficient and move across. But you can see that climbing the rope angled ramp, if you like, on the side here, the climbing frame. That is one of those experiences where it's not quite steep enough to be a ladder and not quite gentle enough to be a stair. And so that provides a really interesting experience as a child to climb, but you wouldn't want to be using that as the main means of getting from your ground floor to the first floor in your house. Here are some examples where ladders actually are the best way of getting around things. And you can see that the main consideration here is lack of horizontal space, lack of availability of horizontal space. And the temporary nature, obviously, of some things. You need to get into your bunk bed just once a day and out of it once a day. And you don't want the stair or the way of getting to the top bunk to occupy all the bedroom space. So a ladder is a great way of doing that, and it's also great fun when you're little. No problem to climb up and down. Likewise, the bookshelf with wheels on their ladder there. You're accessing the books at the top shelf fairly rarely, and you can move the ladder away when you don't need to use that. And also, obviously, loft space in the house. You're not going up and down there every day. So there's a temporary ladder that comes down and goes away, not required. Likewise, going up on top of the roof to do inspection work. You can see the vertical ladder. You can see the worker with a hard hat and a harness going up that ladder. And the reason he's got the harness on is because there aren't many spaces on that ladder. It's probably quite a long vertical distance to traverse, and you're going to get tired moving up it. So the connection, the physical connection between the harness holding the user onto the ladder is very important to provide security and help, because that ladder, the distance in which you're having to use that ladder is probably quite a long one. So here we are. Let's talk about stairs. What's the ambition with stairs? How do we work out what is a successful staircase, a useful staircase? Well, it's about the relationship between the step itself and its verticality. So the step itself that we step onto is called the going, and the step upwards, if you like, the vertical, is called the riser. And there's a relationship between these two things that can be expressed in a mathematical formula. The ambition here is that this relationship, this ratio between these two things, should not impede the forward motion of someone coming on the horizontal plane and then moving up the staircase or moving down the staircase. So it's so that you don't, it will slow you down, obviously, but what it does, it's designed to do, is to not result in you using a huge amount more energy to go upwards or downwards. And that's it. That's how this relationship has been worked out. And the formula is that twice the height of the step plus the depth of the step, the going, should be equal to 63 centimeters. So that's this formula that's expressed here on the screen. Optimal riser-going ratio is twice the height by plus the tread, or the depth of the step, should be equal to 63 centimeters. But within that, there are certain parameters. Basically, the height should always be between 14 centimeters and 21 centimeters, and the tread shouldn't be more than 37 centimeters. So those values, the h and the t, shouldn't be extreme. They shouldn't be, the h should not be less than 14 and not more than 21, and t should never be more than 37. And obviously it shouldn't be a small value either, particularly. So there's an example here for, so 2 times 17 plus 29 is 63. So for example, you could have a step where the tread of the step was 29 centimeters, in other words, the going, the depth of the step, 29 centimeters, and the height of the step was 17. And that would be an optimal step that would fall within the parameters of this equation. Okay, so here we have another diagram expressing this kind of range. Okay, so at one end we get a step that's 14 centimeters high, and if to marry that in our formula, it would end up with a 35 centimeter tread, going up to a step that could potentially be 21 centimeters high, which would have exactly the same tread, 21. And you can see that step is starting to get quite steep. The one at 14.35 is quite gentle. So ideally, one in the middle, 30 degrees-ish, with 17 and 29 is a really good combination to have. So these are tolerable riser and going dimensions that will work, but ideally you would like to have one in that middle range, probably somewhere. So this is where we're aiming for with steps. So once you know this formula, once you know that this is the ambition to produce this energy conservation of verticality, moving verticality, then it allows you to work out and use this formula to calculate how many steps you should have, how to organize your steps in your design. Here's some other things, according to building regs, that you should ensure. Headroom, for example, to the floor above should be a minimum of 2 meters, and all sorts of details. Now you can look in building regs and you can find all of this out. On the course, we're not going to be too bothered about all of this. We do want headroom to be a consideration and landings, but we'll talk about that in a minute. So this might be a way in which you could calculate your stair dimensions. If you use this formula of these 4 steps, it should help you to work things out. So obviously the first thing to have is how big a distance it is that you want the steps to traverse vertically. So you can see in example in step 1, x here is the distance from one floor level to the next floor level. So the top of one floor to the top of the next floor. In this example, it's 230 centimeters. Okay, so what we're going to do is then divide it by what we think would be a useful number of steps. Now, ideally, it should be between 13 and 14 steps as a maximum to go in a single flight. So if we divide 230 by 14, we end up with a step height. Each step would be 16.4 centimeters in height. Okay, so that falls within our parameters. Remember, the h must be a value greater than 14 and less than 21, so 16.4 is good. We could work that out. And now we go to step 3, and we work out how much horizontal space our stairs are going to occupy based on the height and the number of steps. Okay, so we can reconfigure our formula here, and we can see that the height, the breadth, the depth, the tread of each step will be 30.2 centimeters. Okay, so we've got an individual step. It's going to be 16.4 in height and 30.2 centimeters in depth, the riser. So now we can work out by multiplying 14 times 30.2, this equation over here, sorry, this equation down here, 14 times 30.2, we can see that the width of our step, the length of our step, is going to be 4 meters and 22. So in other words, 422.8 centimeters or 4,228 millimeters. So in other words, to to take our users from our floor, one floor to the next floor, that's 230 centimeters in height, they will need 422.8 centimeters of space, horizontal space. And what you'll notice also in this drawing is that we've had to cut a hole in the floor above to allow people, as soon as they come onto the staircase, to move through the space above their heads into the floor level above. So that's how you calculate stairs and work out the space that they'll need to occupy. But of course, there are some other things to think about. The step height should always be the same for each step in a flight. Okay, so you don't want to change the height of the stairs, this individual steps. You might think that's obvious, but it's worth bearing in mind. That is absolutely key, because as you move up and down the stairs, there's nothing worse than it suddenly getting shorter or much bigger. And a single flight of steps should not be longer than 13 or 14 steps. So you can see in the examples on the right-hand side here, there are landings put in to break these stairs up so that we have shorter runs of individual steps. That's an important consideration as well. It is very tiring for people to move up a very long continuous flight of steps without some break, some opportunity to move in a different direction, to change, go back, or to have a rest. Okay, so the landings are an important consideration in steps. So keep the step height the same for each step and no more than 13 or 14 steps in a single flight. And obviously stair width is another consideration. This is a reference from a book called Architect's Data, a very famous book from Ernst Neufert. And it gives you an idea of how wide your stairs should be, or steps should be, given the context and the use of these. Bear in mind, are you expecting lots of people to use your stairs at the same time? Do you want people to pass each other, be comfortably, and so on and so forth? Okay, those are considerations for thinking about the width of stairs. And here's what they look like. So in section, when you're drawing, you can see here, that's compared to a ramp, stairs versus ramp. Stairs occupy a lot less, a lot more compact horizontal space. And ramps need a lot more. This is quite a steep ramp, by the way, a 1 in 6 slope. UK building regulations probably wouldn't let you have this in a public space. It would be too steep. So in fact, to comply with building regs in the UK, you probably have to have an even more horizontal space for a ramp and maybe more than one landing. You can see in these two examples, there's a landing halfway up the vertical space in each of both in the stairs and in the ramp, where your users, as they progress up the stairs or up the ramp, turn and come back on themselves. Okay, and as you can see in these examples, as you move up the space, you need a head clearance to the floor above to allow your users to comfortably use the stairs without banging their heads. And this is how you would draw those two examples in plan. So you can see stairs with an arrow pointing in the direction always goes upwards, and the ramp has got a big arrow on it pointing upwards as well. So ramp up to the landing on the right here, and then up again backwards over itself. And you can see as you're cutting a hole through the floor above in your plan, the plan would show that the ramp is occupying a lot more space horizontally as well. And so when you're drawing stairs and you've got stairs one above each other, here we can see there's a section cut on the right-hand side with stairs going between 3 levels. And this is on the right, how you would draw it in plan view. So if you're drawing the plan for level 2, you're looking down through the space here, and you're seeing the steps coming up to your floor. If you go into the ground floor, and you're drawing the steps going away from your floor, you start by drawing the stairs as they come away from the ground level. As they pass waist height, you put a cut line across here, and then the stairs are above your plan level. You might want to indicate with a dotted line the stairs continue up here, but they're above the plan level. Drawing them in the middle is a little bit more complicated because you've got a floor here at level 1 where you both have stair moving away from the floor you're on. This is this person moving up these stairs, and this is how you draw that, as you did for the ground floor. But you also are drawing through this hole this stair coming up to your floor. This is what's happening here in this drawing. So you've got an arrow coming curved around across the landing and back to your floor. So you're drawing both. They both occupy the same amount of space, the same kind of space vertically. It's just one is above the other. So this is the bottom here. We've got the stair going up, and at the top we've got the stair coming to this floor. That's how you draw that correctly. But we'll look at some examples of that in a minute. And don't forget to allow space to get on and off the stairs as well, landing. So don't put walls right at the end of stairs, or people won't be able to get off your walls, or doors for that matter. You're always going to have landing. Okay, so don't forget to put the landings. Allow space for landing. So here's some examples of some plan drawings of buildings. So here's a house in London with a stair as a feature. You can see these photographs of this staircase made of wood, almost like furniture. It runs vertically through this house. It's not the only stair in this house, only set of steps, but it's the feature step, and you can see that it runs through this core here in the middle of the building, from the bathroom, bedroom level on the 3rd floor, 2nd floor, 1st floor, down to the basement, or maybe then we're going to the basement, 1st floor, I don't know. Okay, and so you've got 4 levels at least. 1, 2, yep, with the stair running through that. So in section, you can see how it's drawn there. We're obviously looking at the staircase in this section rather than cutting through the staircase in this section. You can see the heavy line is indicating the surfaces that we're actually cutting through. And you can see that there is a step down into the bottom layer of this house, or the ground floor or the basement floor, from the street level. And at that point, the section is cutting through that stair down there. And that's why we're seeing the steps rendered in black here along the bottom. So let's move to the next. We can look at some plans. This is the ground floor plan. So this is that lower level that we're looking at now. You can see where the section line has been cut through in the previous section. You can see it's right along this edge, and we're looking upwards on the plan here, and that's why it's cutting through here on the right hand side. You can see these stairs, these steps which came down from the road level. You can see the arrows pointing up, because that's the up direction of the steps coming up out of the house towards the pavement. Okay, and here we have our central feature staircase in the middle of the house. And you can see from the ground floor, in our close-up view here, the steps leave the ground floor and begin to curve away. They move above the plan height, and then the stairs are in dotted line because they continue above the plan level as they move up from this floor. So you can see the stairs continue above the plan cut line. The stairs are coming up from this floor and indicated with the arrow. And you can see also in this house there's also a stair at the back. It wasn't revealed in the section because it was hidden behind these walls and so on. But there is another set of stairs back there in the plan. Okay, let's now look at a different plan of another floor, same building. Okay, so we're now on the 1st floor, and we can see once again that spare staircase, if you like, the other one is there in the back. You can see that it comes to this floor from the ground floor, and we see the whole of it. So there's basically an opening in this floor that reveals this whole stair coming up to this level, to the study at the top here. And here's our central featured staircase in the middle of the house. And we're on the 1st floor here, so we can see that there's a break line drawn in the way that the stairs are drawn. We can see that the stairs are coming up from the ground floor, arriving at our staircase here. We can see this on the left-hand side with this arrow pointing to the hole. And then we can see, if we move across to the right-hand side of the drawing of these close-up, the stairs from the 1st floor continue upwards again. So there's another flight moving up to the next floor. And they overlap each other. Okay, so one is coming up under, one is going away up and over. And we've got this break line between the two to show that these stairs are occupying the same vertical space, but one is under and the other is over. So that's that house and how it is rendered, how it's drawn, this complex staircase arrangement. Here's a different building in Belgium. It's a much smaller building. It's a flat or a small house. Once again with a series of stairs moving around and a little bit more complex floor arrangements in terms of straightforward floors. So the way that this is drawn, if we look closely, we can see that there's a garden at the back. is a stair coming up into the house from the garden at the back. It should have an arrow on it, it hasn't got one. But it would be coming up and into this little landing as a door into the back of the house, into the dining room. If we move to the front of the house, we can see that there's a doorway off the street. As you come in, if you go to the right, there's stairs going up to a landing and then into, once again, into the same dining room. So from this drawing, we get the sense that, okay, right, street level is lower than this main occupation level, this main accommodation level. It's elevated above the street somewhat. Okay, so only a few steps up, not a full 13 or 14 steps, but 7 or 8 steps up. Okay, so what we expect from as a spatial experience in this building is to come in off the street, through the door, into this hallway, and then up to get into the main space. Okay, and then we can also look, if we look to the left here as we come in this door, we can see there's also steps coming up to this hallway from somewhere else. So just from this plan drawing, we get a sense that there must be a basement. There must be a lower level because we've got steps coming up to this landing. So we could come in the door, and instead of going up into the main accommodation, we could come in and go to the left-hand side, and we'd be going down to the basement. And then if we move to the other side and go into the accommodation space, we can go through this door, past the tables and round. And if we look here at the bottom part of the drawing, we can see also there are stairs going upwards again from this accommodation space, occupying the same vertical space as the stairs coming up from the basement. Okay, so we can see that there's more space above and more space below, given how the staircases are drawn in this plan drawing. So let's have a look at the next drawing, and we can see that this is the basement plan. So this, if we went to the left in the previous drawing and went down the stairs, this is where we would be emerging. In this red circle here where the red arrow is pointing, there's an indication of stairs going upwards. So we'd be coming down these stairs, and this is what we would find in this basement. We'd find a toilet, a washing room, another room at the back, and a window out into the garden, by the looks of it, and some machinery and so on hidden away in there. Okay, so that's what we'd expect to find in the basement. And to get out of the basement, obviously, we'd be going up this step again, and we'd appear in the hallway above. Just to confirm those things, here's the section of that building. You can see where it's cut in the plan through here, and we can see, yes, right, okay. So we come in off the street, and if we draw the section here, then we're drawing it through this line, drawing this through the staircase that takes us down to the basement. All right, okay, we can see what the window is like, looking out into the garden. Okay, so there's no access to the garden, but we'd be looking through at like knee height into the garden. And because of the sections being cut through very close to this wall, the lower wall of the house, we're not seeing the stairs going up to this dining room area. The section will have to be cut a little bit deeper into the house to give us that view. Instead, we're seeing the steps going up to the various other floors above as well. And we can see that actually there's a mezzanine or a balcony area in overlooking the dining room and so on, where we can see the little steps going down at the garden. So it all makes sense, and we have a picture here of what it looks like in reality. So those are the drawings that express that design and talk about that design. And those are accurate drawings of those spaces, and that's how we interpret them, and that's how you draw those staircases. And of course, these are things that architects have been doing for a long period of time, and this is an example of spiral staircase, for example, how you draw it in elevation or section, and how you draw it in plan. And a famous example here, of course, Villa Maria Alvar Aalto in Finland. Okay, so things to think about when you draw stairs and ramps in plan and section. The horizontal and vertical space that is occupied by your stairs. Think about that carefully. Think about getting more out of your stairs and ramps than just ways of getting from one level to another. Think about some of the examples I showed you, and you look at other examples of the opportunities that stairs provide to cut through the vertical space in your building, to let light in, to provide visual connections between spaces. Don't forget about headroom. As you go up stairs, as you go up ramps, your head needs somewhere to go. You'll need to cut an opening in the floor above to let your users get through. And don't forget, people need to get on to your stairs and off them. So make sure you've got landings. Think about the width of stairs too. What you want your stairs to be used for? Do people need to pass each other? And remember not to have long flights of stairs. Keep it to 13 or 14 steps before you have a landing or a way of changing direction or a break in the stairs. Okay, those are important considerations when you're designing and drawing stairs and ramps. And this is the building regulations that you'll find. It's all to do with health and safety. If you want to have, don't worry too much about those for now, but that's where it is. This is a really excellent book that helps you think about stairs and staircases as well as many other technical details in your building. Fortunately, it's available as an ebook, which is terrific, and how to get hold of it is here. So this is the links to various references I've used in this presentation. So good luck with your stairs and your ramps. Make the most of them. They're great.